Welcome back to Topic 5 for Algebra 1, Solve Problems Using Proportions. In Part 1, we're going to define what a proportion is and then reference back to Topic 1 when we learned about the cross-product property and apply it to a few examples. So first, let's define what a proportion is. A proportion is two fractions set equal to each other. And this is really important because oftentimes a common mistake that I see students use is they apply a cross-product property, which we'll get to in 1 minute, when there isn't a equal sign. So maybe when there's a multiplication sign in between two fractions. But here we need to really focus on a proportion is when the two fractions are set equal. So we see that equal sign in between them. So speaking of the cross-product property, we learned about that in Topic 1. So just for review, if we have, and again, we're going to use variables here, but we would replace them with numbers, or we'd probably see them with numbers in some examples that are coming up. If A divided by B equals C divided by D, then if we cross multiply, AD, or A times D, is going to equal B times C. Now we have a few conditions. So this is for when B and D both do not equal 0. So B cannot equal 0 and D cannot equal 0. And that's because they're in the denominator here. And we cannot divide by 0. If we divide by 0, then it is undefined. So let's use what we just learned and apply it to some examples. In our first example here, we have y divided by 50 equals 2 divided by 5. So here we're going to try to solve for a variable of y. We're going to apply the cross product property and cross multiply. So here we have 5 times y, or 5y is how we would traditionally see it. Oftentimes we see the number come before the variable, equals 50 times 2. Now what we're going to do is simplify. 5y is still going to be 5y, and then 50 times 2 simplifies to 100. Now, since our goal ultimately is to solve for y, we need to think about our inverses, so what we dealt with in Topic 3. All this is a one-step equation. Since this is really 5 times y, in order to undo multiplication, we're going to apply division. And using the property of equality, what we do to one side, we have to do to the other. So 5y divided by 5, the 5's divide and cancel just to 1y, but since 1 is a humble number, we just write y. And then on the right-hand side, 100 divided by 5 gives us 20. So y equals 20. Moving on to number 2, here we actually have what's called a binomial. So this is two terms with our variable here. And minus 2 divided by 50 equals 6 divided by 30. So we're still going to cross multiply, use the cross product property. But here we have 30 times the quantity of n minus 2 equals 50 times 6. So on the left-hand side, my instinct is telling me to apply the distributive property. Because this is really 30 times n minus 2, this 30 is going to apply to each part of this binomial. So we have 30 times n, which gives us 30n, and then 30 times negative 2. Now make sure we keep that sign with that number. Whatever is in front of it is the sign that's associated with it. So 30 times negative 2 is negative 60. On the right-hand side, we have 50 times 6, which gives us 300. Now what we have here is a two-step equation. So looking at this, we ultimately want to solve for n, but we really want to get rid of those stragglers first. So who is third wheeling here? We have this 60. Since we see a minus 60, the inverse of subtraction is addition, so we're going to add 60 to both sides, keeping that property of equality. Negative 60 plus 60 adds to 0, so it will just cancel out, and I'm going to bring down my 30n. On the right-hand side, 300 plus 60 gives me 360. Now we have a one-step equation. So similarly to example number 1, this is really 30 times n. We have multiplication here. So in order to undo multiplication, we're going to apply division. So we're going to divide both sides by 30 since we want to isolate that n. Dividing both sides by 30, on the left-hand side, 30 divided by 30 is 1 times n, or just 1n, or oftentimes we just write n, since again, 1 is a humble number. We don't always write it. On the right-hand side, we have 360 divided by 30, which simplifies to 12. So n equals 12. Moving on to our third and final example for this part, we have 6 divided by 4 plus 2x equals negative 2 divided by x minus 10. So first off, what do we notice here? Well, we have the same variable of x, but we have it in both fractions. So it's going to take a few more steps just to simplify. We're still going to apply the cross product property. So when I multiply, I get 6 times the quantity x minus 10 equals negative 2 times the quantity 4 plus 2x. Now the larger values, typically they have like more space. In this case, we have the two binomials. I like to write those afterwards just because visually for me, it's easier to see when I have to apply the distributive property. I could also write it, for example, 4 plus 2x times negative 2. Again, I will still have to apply the distributive property, but just keep in mind that these are equivalent because multiplication is commutative. We can flip the order and still get the same product in the end. So let's go back to 6 times x minus 10 equals negative 2 times 4 plus 2x. I'm going to apply a distributive property. So we have 6 times x, which gives us 6x, and 6 times a negative 10, remember that negative sign is associated with the 10, gives us negative 60. On the right-hand side, we have negative 2 times 4, which gives us negative 8, and negative 2 times 2x gives us a negative 4x. Okay, now thinking back to topic 3, when we wanted to get the variable on one side so that way we can easily isolate it, I'm going to draw my vertical line down here and decide which side do I want my variable to be on and which side do I want my constants to be on. Let's say I want my x to be on the left-hand side and my numbers to be on the right-hand side. So in order to do this, I'm going to move any variables that I see on the right-hand side so that they ultimately end up on the left-hand side. I see this negative 4x. Since I see subtraction, I'm going to add 4x to both sides. And again, I'm going to line this up with my like terms. So I'm just adding the 4x on the left-hand side to the 6x. It is not a like term with that negative 60. On the right-hand side, negative 4x plus 4x, that just adds to 0, so it will be eliminated, and I'm just left with negative 8. On the left-hand side, we have 6x plus 4x, which gives us 10x, and then bring down that negative 60. Now what we're left with is a two-step equation. So again, I still want to get my constants on the right-hand side because my x's are only supposed to be on the left-hand side. So this negative 60, I'm going to move. Since it's subtraction, I'm going to apply addition. Add 60 to both sides. On the left-hand side, negative 60 plus 60 adds to 0. So I'm just going to be left with 10x. And on the right-hand side, negative 8 plus 60 gives me 52. Now all I have is a one-step equation. So I have 10x equals 52. This is really 10 times x. So the inverse of multiplication is division. I'm going to divide both sides by 10. 10 divided by 10 simplifies to just 1x, or just x. And 52 divided by 10, this would simplify to 5 2/10, or 5.2. So x equals 5.2. And that was part 1 for topic 5, solving problems using proportions. Thanks for watching.